Uh, Continuing our theme of CHTC speakers, our next speaker is Todd Miller, who will be talking about common input files.
Yeah, this will be part two of a talk that I gave last year. Not that I expect very many of you, if any of you, to remember it. So I'm going to go ahead and start from the beginning. What are common files? We take this observation, and we phrased it with many because we forgot that Maroon doesn't like it. So I'll say some, even though the slide says the other word. Jobs need file to run. Some of those files are the same from run to run. And some of those jobs, often, are submitted as part of a group, either as a job list or a DAG. And jobs from that same group often run on the same machine at the same time. That's what I talked about last year, and that was one way that we could exploit some of these scheduling peculiarities of the Condor system. But it's actually more common for a job from a group to run immediately after another job from a group on that same machine. And so the talk this year is going to be about the nice things that happen as a result of the new code we've added, new feature to exploit that scheduling occasion. Bottom line, Condor should not need to, and now does not need to transfer all of these files every time. So a little graphical representation here. On your left, we have what we were doing last year with concurrent usage, where these boxes, I'm sorry, I'm putting up the wrong part, are jobs. At least one job running at the same time. We can kind of keep the files that are reusable between those jobs alive, as long as any one of those jobs survives. Here on the right, we've added this thing called a data slot, where we keep those common files separate and apart from the jobs. And that lets us have this big gap here, where big might be 3 seconds to 3 minutes, whatever, where we don't have to transfer the jobs, even if we can't quite immediately or quite concurrently have another job running. And that's a much more common use case. Those of you who are more familiar with Dagman and with keep claim idle, that gap right there is in fact the exact same thing, just applied to sharing files as opposed to sharing computational resources. I'm going to say it again because it's important. HTCondor no longer needs to transfer every file every time. Now, because we're keeping these files off on their own, and because of the technology we elected to use for this mapping process, which I forgot to point out on this slide, we need some way to get from this repository of shareable, reusable data to the place from that repository and make it show up in the places in the jobs sandbox directory where it expects them to be. That process is called mapping. The way we implemented that mapping under a certain set of conditions that I'm going to skip here for time reasons, it doesn't require any additional disk space or additional disk bandwidth. You do your initial download, it goes into the special, data slot, which we were calling slot 0 for a while. You may have heard that term yesterday. And we don't have to copy it again, and we don't have to use that disk space. This is not just an efficiency, a quantitative improvement. It is a qualitative improvement in some ways. When you're looking at these jobs that, as Danny was talking about earlier in the week, use 750 gigabytes worth of data, maybe you can't fit more than 1 or 2 of them on your 100-core machine because the disks just aren't big enough. But if it's only an 8-core job, it means you're throwing away this opportunity to run 12 of them or so at the same time. Hopefully, we expect, well, I can't promise anything for the 26.0 release. We expect and hope that this will be working by then without you having to do anything. And that's not a benefit just for the user who's submitting that job, but because it kind of uses these cloaked resources that it was hiding because its data requirement is so much larger than its corresponding CPU or memory requirement. Those jobs will run faster, so will all the other jobs in your cluster. Faster, lower latency. What specifically is going to be showing up in the next stable release of Condor? I want to emphasize common container images. That was a technology we couldn't support, or a use case we couldn't support in 25. Individual job submitters can specify that this particular job's container image is common. There's a JDL on the screen there for you to be able to use. My hope and expectation is that this is something that will work so well relatively shortly into the 26 stable series that your administrator will be able to say, yeah, that's just true by default. It's an optimization that the user shouldn't have to know about, shouldn't have to worry about. And so our goal is to make that optimization transparent to your submitters. We can't actually reach that 100%. As you may remember back from 25X, we do have these events in the job event log that are specific to the common file transfer to make it clear what's going on. So if your user is paying attention, they will notice it happening. You as the administrator might notice these data slots. They show up, they're just called data, typically 1, 2 for reasons. Having said all that, I also want to say that non-container common files can still be shared using the same method I talked about in last year's talk. Before I go any further about how wonderful things are going to be, I want to talk about the limitations, and then as Maron was suggesting, talk about error handling a little bit. Common files must be immutable right now. They must be read-only. That's how we get these disk space efficiencies. The container images aside, you have to explicitly specify them, which means that you're going to have to interact and talk with and guide your users a little bit more to get this benefit for you, the administrator, of the reduced bandwidth usage. Your users, of course, are going to see shorter job latencies as they're going along when they do this. It only works in the vanilla and the container universes. This is strictly an engineering effort, not particularly interesting technically. Only works in partitionable and dynamic slots. I hope very few of you are using static slots and this never comes up as an actual problem. It doesn't work on Windows, again, just a matter of engineering effort. The most interesting, or the two most interesting points here are the bottom, actually. Right now, you can't reuse common files between submitters, and that's a policy decision, right? There's no technical reason we couldn't do it. We've decided not to do it for the same reason that we don't do it for normal file transfer, right? You don't expect the way that we get data from one place to another to have any effect on how private or well controlled access to that data is, and so now it still doesn't. This last statement, for those of you who are reading ahead, looks like it makes no sense. I have a whole other slide to explain it, but catalogs cannot vary within a namespace. And so a catalog, I've been talking about common files. We don't actually share common files individually. We share them as a unit. The common file catalog, it's a named list of common files. So examples you might see in a job ad, we might say your container image is its own catalog and it's got a particular name. You might tell us my common input files, I have this big old database and I'm going to be generating some PDFs automatically. I'm going to have my NSF acknowledgement ready to go. A catalog's namespace, I know this is near and dear to your heart, Maron, is a scope for catalogs and a name, a value within that scope. Another sentence that doesn't make a lot of sense right away. First example here is the most important one. Cluster ID would be a scope, and 170,000, you're just getting your big program started, would be a value within that scope. And when we talk about that, what we're really saying is that when we look for this catalog, a name, right? We're looking for the name of the catalog. We're trying to decide, is this actually the catalog that you wanted to share? Right, again, this is a policy decision and not a technical one. And the answer is, it'll be yes if it's the same from the same cluster, if you submit it as part of the same job list, for instance. We can also make that answer be yes because DagBand submits its own cluster ID, has an attribute called DagBand job ID, into every job that it submits. And so that's how we intend to support common files across DagBand. For technical reasons, for those of you who aren't familiar, it tends to be that you want to submit one job per node in a DAG, which obviously limits the opportunity for sharing within a particular cluster. This is a backend mechanism only right now. Cole, I'm going to blame, unless his name is Claude, I've forgotten already, for not having a UX ready to go. But to be fair, this is another one. It was a technically hard problem. He hasn't had a lot of hard time to work on it with working code yet. Another topic near and dear to Maron's heart is failure, of course. We're talking about the grid, even if we don't use that word anymore. The mean time to failure is now. So I'm going to talk about what happens when things go wrong with common files. The key thing here, as I mentioned earlier, is that this is an optimization. It is not a requirement. When you turn it on for your job or for your users' jobs, they will continue to run. We will try to run them even on places where we can't do common file transfer. So if you got a bunch of old EPs in your pool for whatever reason, jobs will continue to run there if they get assigned, if their AP gets assigned those resources. If common files transfer fails, all of the jobs that are waiting for that transfer to finish will return to idle. You don't have to do anything. You don't have to look at a hold code. We just go ahead and, excuse me, try it again using normal file transfer. Some of you are thinking that sounds awfully fragile, and it is, and it's very deliberately fragile. Partly because, as we've been mentioning throughout the week and again this morning, reporting is really hard. I don't feel like we have a really good reporting mechanism for the situation yet. Some of you may disagree that we do well reporting these kinds of errors in the normal file transfer situation, but at least hopefully everybody knows how to deal with them. You've got your processes, you've got your particular job policy expressions. And so we fall back on that. We talked about, or I mentioned common file mapping as a separate step. That's a new step that we had to add in order to get this to work. If that fails, the job that tried to do it goes back to idle, right? It gets another chance to use common files. The second time that happens, we assume that something has gone wrong in a way that we don't understand. Fine, we'll fall back on normal file transfer for every subsequent job in that in that namespace. Finally, and perhaps the most important point here, if a data slot vanishes for whatever reason, it gets evicted, you accidentally shoot a starter in the head, a shadow gets confused and wanders off, every job that mapped those files will continue unaffected. And that is an important part of this design because it leads to, we don't have to even consider a whole bunch of possible error cases because we don't have to interrupt those jobs. Summary of visible changes in 26. Actually, this first one was available in 25 if we're using the testing common files framework. Common transfer events are in the job event log. I alluded to this earlier. There's now a B for blocked state. So if you run Condor Q and see some jobs in B state, what that means is they have been assigned resources, but they're waiting for a common file to transfer, common file transfer to finish. Data slots, as I mentioned earlier, basic idea here. We had this kind of invariant where there were all of your available resources are in a partitionable slot somewhere, unless they've been assigned or allocated, in which case they're in a D slot somewhere. A data slot is a new type of D slot. All it does is hold disk in our allocation scheme to keep those common files alive and make sure we're accounting for everything properly. And of course, you should see reduced bandwidth usage. I cannot give you any numbers on that. What I can say is that in my testing, by increasing the amount of data that's common, decreasing the job length, and increasing the, I'm sorry, I've forgotten the name, how long you get each resource individually, I can make that percentage savings almost as large as I want. So there's a lot of room here for benefit, but it is going to depend on your job mix and your pool scheduling policies. Much more briefly now, I want to talk a little bit about what we're trying to do, what we're hoping to get done in the feature series in 26. So things that I hope there will be a part 3 to this talk for. I mentioned, I hope, earlier that one of the, I put it on a slide, I didn't say it out loud. One of the exceptions to being able to use EPs for common files, we can do it for EPs that have LV enabled, that are using a relatively new feature to help control the disk usage of jobs. That mode is much less efficient than we would really like. It's copy-based. That means some of those benefits that I was talking about earlier don't apply to this particular implementation. We have a technical idea using bind mounts that should be as disk space and bandwidth efficient as using hard links, but it doesn't have the same guarantee reliability enforced by the kernel that we have for, the copy and the hard link based solutions. Better scheduling, of course, right now, as I was implying earlier, we're really taking advantage of peculiarities in the way that Condor runs in order to share these common files between different job instances. Obviously, we could try doing some steering via rank. We're going to run some experiments to see if that works. If it does, we don't have to do anything else. If it doesn't, or we don't see the benefits we're expecting to see, we can try and start thinking about what other policies we might be able to implement, some of which might be to prefer to give an AP slots on the same EP. Normally, if different slots become available, they have the same matching power, the same rank. We don't really care. We can just assign them randomly effectively. But it would obviously be beneficial to give a single AP as many slots as a single EP as possible when that allows us to save bandwidth. You may have been wondering, how do we decide when the staged files go away? What amount of time between two jobs is too long? It's very simple right now. It's a lease. It's a certain amount of time. Every job or every common file gets the same time. Obviously, there's a lot of space there for improved policies to give people more control about how their disk space is being used. The most speculative idea on the slide is down here at the bottom. we can do a common file transfer and then we can do a copy. This does have some disadvantages in that we're using more disk space than we really have to. But it does have the advantage that now we can actually look in an automated way on the AP at the jobs you're running and say, oh, yeah, actually, you didn't tell us about it, but these files are the same between these 10,000 jobs. And this is looking at weakening and tweaking this requirement that common files be immutable. That's where that is coming from. Sorry, so that's because it does use more disk space and more disk bandwidth, it's not appropriate for every situation. So part of the trickiness here is going to be an interesting scheduling problem and how do administrators that might know better than we in our automatic senses control that a little more. Obviously, a lot of room for usability improvements here as well. I mentioned scopes and catalogs in part for these first 2 points. It would be great if users could sign up and say, yeah, by the way, every time I say I want to use a catalog the common image busybox.sif, it's the same busybox. It's okay. You can go ahead and share that across my different jobs. And very similarly, we could have a project scope for catalogs. We have user and project records in the AP now. We didn't mention those this year. I think we mentioned saying them that they would be showing up last year. Projects have users. We could have somebody upload or specify a catalog or say they're a particular experiment's runtime. And then they add and remove their graduate students who are actually going to be using that in their jobs. That's a little easier for them management-wise, pushing out the updates that way. It's also an opportunity for the AP to be even smarter and share files across even more jobs. We do, again, the backend support multiple catalogs per job. That's how we get both your hand-specified common files and the automatically specified container image files to work together. There's a lot of potentials here for different ways to support explicit specification, whether that's automatic or by hand in DAGs. It may also be useful to help address this kind of issue that Cole alluded to, where we don't right now have a way to specify more than one input transfer list at the same time. Same sort of issues are going to happen for common input files, of course. And so if we could just support as a first-class option multiple catalogs per job, hopefully that becomes less of a problem. Thank you so much for your time. And this is the acknowledgement slide. Questions?
Thank you, Todd. Are there any uncommon questions for Todd?
It's okay if they're common, we can share them.
I don't know about common, but thank you for working on this. I think this is going to be a very big win for
I sure
my
hope.
cluster release.
So to put some cold water or whatever on all this, and first, I feel that a key potential gain is reducing the load on the object store. It's not the network bandwidth. I know that it gets everyone excited, and it may be useful in some OS pool situation where we are running on campuses where the amount of traffic that we are generating to the network becomes an issue. And I think it also that we have to keep in mind is how all this and the concept of staging in Pelican and OSDF play together. That is, so I feel that there is a potential here to improve throughput because we can support a large number of jobs running concurrently if we don't have every job going to the object store and fetching the files, but they are stored and reused locally. That is, so I think this is an important part of this. I always have the concern, and I will continue to have it, that all this will explode in our face the first time that we provide a job the wrong copy of the data or the container or whatever, that we think that we know what we are doing and we were about to save a transfer and we delivered the wrong thing. And then we have to send somebody a note saying, please, you have to pull back your PhD because the data that you used for the most recent conclusion was wrong. And I feel that using the catalogs and using all these naming has also challenges in terms of the provenance, which is related to what I just said. So it always was, okay, can we save network transfers? And I don't think that that is A, what we have to focus on, and B, we have to be extremely, extremely careful not to be smart and creative because it will explode in our face.
A question from Zoom?
Yep, we have two questions from Zoom actually, so sorry to capitalize on time here. First is there a degenerate error storm when an EP side file system wedges and 1,000 jobs which were all using common files suddenly and simultaneously revert to file transfer? If this happens, will the AP throttle them or does throttle not work in that case?
That is an excellent question, one I have to think about more closely. I know for the bind mounts case, we took a careful look at what the Linux kernel limits for that were, and it seemed like in almost all cases that wouldn't be a problem. I have to admit I didn't look for the hard links. My belief is that there is no effective kernel limit for that. So yeah, it's a question we should do some more thinking about. Thank you.
Second question is, will the base name of the file be sufficient? What if the AP has different files with the same name? If this feature is enabled, then will HTCondor detect that files are actually different even though they have the same name? Or is it up to the user to ensure uniqueness since the assumption is that common files are immutable?
The assumption is that common files are immutable. One of the reasons we are going to start out by asking you to opt into these and be explicit about them is to make sure that we don't make any mistakes like that. But what I want to say, also partially prompted by what Marone said, I only actually in my example talked about files on disk and base names, and partially that was for space. But it does in fact use the exact same mechanism that normal file transfer in Condor uses. So you can in fact just directly write a Pelican URL in there. And everything that we do to make sure you get a particular and specific file from a submit file, even if it has a relative path, we continue to do for common files.
Okay, Danny, and then Frank.
Yep. So one question that I had was in thinking about AlphaFold and how we can take advantage of this. Often, at least at CHTC, we have containers that we build for users and we post them on a OSG public or CHTC public OSDF namespace. Does it make sense if these are containers that we know staff has made, we have the provenance, we have all the information for that. Does it make sense to have 10 users that might land on one EP all transfer that container individually because it's at the user level that we're doing common files? Or is there a better option of saying, hey, this is a trusted source, let's, transfer once and share across all those jobs?
I think I'm going to answer that by referring to Marone's statement about let's not be clever. If it turns out that ends up being a potentially very large source for efficiency, we can start talking about stupid things we can do to address that. But my feeling here is that you're going to see enough of an improvement that we will have higher priorities than working on that sort of specific optimization.
Awesome, thank you.
So I can't resist and comment on Miron's comment. Sorry. So I think one of the things that I like a lot about AI is that it clarifies responsibility. If I am a lawyer who blindly uses AI, put it into some legal document and send it to court, and what I send to court is bullshit, it's my responsibility, not the AI's responsibility. And that applies to everything. If I'm a grad student trying to get a PhD and I rely on any tool, doesn't matter what it is, and that tool produces bullshit, it's my responsibility and my advisor's responsibility to actually have enough control over the science that I do, that I discover that I've just been handed bullshit by this tool. And in that sense, the tool provider has a responsibility to do the best they can, but they're not responsible for my PhD thesis. I'm responsible for my PhD thesis. And I think that is very, very important to remember. And it gives me actually, makes me sleep well at night as a resource provider, because it's ultimately not my problem. If somebody does science on my systems, with my tools, with whatever, and they fail to find errors, that's their problem.
So maybe I am conditioned by one experience that I had when I developed a discrete event simulation package that was used quite a bit. And it included a pseudo-random number generator. And I had nightmares that the generator is biased. And I had actually once a case that one of my colleagues who used it simulated a paper of somebody else and got different results. And I said, oh, something. It turns out that there was a bug in the other paper, but that's a different story. Yeah, maybe I'm conditioned, but I still feel a responsibility when I deliver data to deliver to you what you asked for. And I'm getting concerned. And by the way, we had some security problem in the hardware because of speculative execution to save us something, and then we really opened the door for a mess that cost us a lot. Yeah, somewhere we have to assume that researchers do due diligence, but still, there is a trust layer there. So that's definitely a subject for discussion over dinner.
Sure.
Yes, Doug.
So this, I think this is very nice. I share some of the concerns about caching in a very broad scope. Now, we've done a lot of work with data management in workflows to cache on the workers in Taskmine. I'll say a little bit about that later. But one thing we did from the beginning is to say, we're only going to exploit shared data within the context of one workflow. So one user, one namespace, and because it's a workflow, we've already enforced data is immutable once created. And so there's sort of a closed system. Now, I've been involved in many projects where the goal is to cache data and you have to make sure that it hasn't changed. So what do? You checksum it. And for the first 5 minutes, this sounds like a great idea until you realize that you're spending all your time checksumming and not doing any work. And I think the underlying problem here is really our storage systems are not oriented around this idea that data really ought to be immutable past a certain point. And I think if we were organized around storage systems that, Unix seems like such a good idea at first blush, right? But it turns out it's got some problems. If we had a storage layer that was organized around the idea of you create something, you publish it, and then that's it, then all this would become very much easier and serve the needs of HTC. And I don't know, I'm looking around now for Brian and Pelican and whether things are going.
He ran away.
But Doug, the problem with that, and we are going back to file system like, what was it, VMS, the old DEC system, then you're getting into versioning. Because if it's immutable, it has a name. and what was it? We want a container library. Wonderful. We all share it, but then we want to update the container. What does it mean? Do I use the, in the very early days of Condor, when you said this is the executable, we actually copied the executable and say, you told us to run this executable, so I will run this executable. If you modify the executable after you submitted it, it's not the one that we are going to run. So even this immutable, what is the job? So it's we have to continue to think about it. It's an interesting world, because when we are going to Pelican and say we can do staging because it's immutable, then people come and say, but we are used to modify this is the input, we change something, but so then suddenly you have to deal with namespaces and versioning. Give me the latest version of this object. Now you have a completely new semantic thing. Latest picosecond.
Let's give a final round of applause for Todd.